Hello again. Today we're going to talk about intercepts. There are two types of intercepts. The x-intercept is wherever the graph crosses the x-axis, and the y-intercept is wherever the graph crosses the y-axis. Let's take an example here with this graph. We see this line here crosses the x-axis at x equal 10. So x equal 10 would be the x-intercept. In fact, the coordinate right there is 10, 0. If we go down on this side here, we see the line crosses the y-axis at y equals negative 5. So this is the y-intercept. Y equals negative 5. And so that coordinate actually would be 0, negative 5. So we have an x-intercept of 10, a y-intercept of negative 5. Notice, when x is 0, we get the y-intercept. And when y is 0, we get the x-intercept. Now, intercepts are nice because we can actually use intercepts to draw the graph of a straight line. Let's graph a linear equation using the intercept method. In other words, let's find the x and y intercepts for this equation and then plot the graph. We have the equation x minus 3y equals 6, and we want to graph it by finding its intercepts. Okay, if x is 0, we have a y-intercept, and if y is 0, we get an x-intercept. Okay, so let's find the x-intercept first. In other words, we set y equal to 0. Y equals 0 means we have x minus 3 times 0 equals 6. Well, 3 times 0 is 0, so really we're just going to have x equal to 6. And that's the x-intercept. Okay, so the x-intercept occurs at 6, 0, at the point 6, 0. All right, if x is equal to 0, we're going to be looking for the y-intercept. If x is equal to 0, we plug a 0 in here for x into our equation. So we get 0 minus 3 times y equals 6. The 0 is going to drop away, of course, so we get negative 3y equals 6. If we divide both sides by negative 3, we get y equal to negative 2. And now we have the two intercepts. We can now plot this on the graph. So we plot the points, 0, negative 2, 0, negative 2. That's right here, that's the y-intercept, where x is 0. And the point 6, 0, 6, 0, that's the x-intercept. And then we join up the 2 points with a line. And so here we have our line. And in many cases, you need 3 points to plot the line just to verify. So, for example, if we had let x equal 3, and I plugged it into my equation here, we'd get 3 minus 3 times y equals 6. And then we would get negative 3y equals 6 minus 3 is 3, and y equals to negative 1. So, there's a third point. X equals 3, y equals negative 1, and we can see that actually does fit. Just to verify that we've drawn it correctly, sometimes we put in another point. So there's a method of drawing the line using the intercepts.